Cool, thank you. I'm going to blame our marketing department for the darkness of the slides. Everybody has cool hip backgrounds on their slides now, and you can't see them in a bright environment, but hopefully you can read the text as we go through. So yeah, my name's Ollie Deakin. I'm a principal software developer at Snowflake Software. We're a small business down in the kind of centre of Southampton, so we're just around Bedford Place. Just to give you a really quick intro into what we do so you get a little bit of context of kind of what we're building and why we build those systems. These are our founders. We've got Ian and Eddie. We started up in 2001, so we've been around for a little while. And in 2015, so originally we were kind of in the geospatial area, so we worked close with groups like Ordnance Survey. And in 2015 we pivoted into aviation, and now we are primarily an aviation solutions company. And we're a size of about 35 people, so we're fairly smallish. That covers all of our departments. That's marketing, sales, HR, absolutely everybody. Our development group is fairly small, I would say, sort of maybe 10 to 15 people. I'm looking at Andy and Nick, who are hiding in the audience here. But what do we do? So our kind of key aim, I suppose, is to claw the aviation industry into the modern age. So this might be a concept that some of you are familiar with. It's the aviation industry is still in a world of software and hardware delivery that is probably from 20 or 30 years ago in terms of practices. Agile, they don't know what the word means. They think it means you're jumping around, you're very nimble. It doesn't really, they don't understand that in terms of the actual delivery style. But they're approaching a really serious problem, which is that as the capacity of our skies becomes more and more full, the ability for air traffic control to be able to manage those flights becomes harder and harder. And what they're finding actually is because they're built on processes from 2-3 decades ago, which are still very manual, very human to human, they're actually reaching a boundary where they cannot squeeze any more flights. They cannot get any more efficiency out of the system. And so what we're starting to do is build systems that allow them to interoperate in a more automated way. So data exchange between air traffic controllers from nation to nation, for example, is one of the critical things that we do. So that's kind of a super quick overview of why we exist as a company now. In terms of what we do, we build flight data processing systems. So it's all about ingesting lots of different types of data, aggregating it together, processing it, and making it available effectively with some quality control to some kind of validation of the quality of that data that's coming in. Another really important aspect to it. But it's high volume, it's real-time data, it's very event-driven. So we build our kind of core design principles are around event-driven processing and also microservices style architecture, which means we've got a lot of very small components deployed together in a cluster on a set of distributed hosts. So our kind of smallest deployment is 3 servers, which tend to be reasonable sized things, but we go up to any number. We can scale that out horizontally. So we're kind of perhaps at the opposite end of the scale from perhaps some of the embedded systems that many of you are familiar with. We're kind of going more into that, into the kind of, well, we have 2 different channels that we deploy into. One which is cloud-based, so we provide a kind of a public hosted cloud service on Amazon, and also some private services there for customers as well, systems like this. But we also do on-premise deployments as well, where we actually go into some of the air-gapped sites. The UAE is a good example of that one. They don't have any internet connection there. There's nothing, you can't go and deploy onto their site just from our offices very easily without a kind of a private VPN connection. And so we go in and we install on their sites as well. So we provide them that kind of distributed cloudy style system, but we actually take in and put it on some boxes in their data center for them. And we're primarily an agile shop. We love agile, but our customers, the industry that we work in is very regulated. They are, again, in terms of practices, I mean, as I said, they're kind of a little bit behind where maybe the cutting edge of software delivery. Yeah, I don't think you can even perhaps call agile cutting edge anymore these days, but it's still considered what we do very advanced. So we have to kind of work a bit of a balance between how we like to deliver software, which is agile, and how our customers like to approach it, which is quite systems engineering and waterfall driven. So that's a really quick picture of what we do and why we do it. So the next thing, wow, these icons are really big when they're up on the screen, right? So as I said, we build a microservices style architecture. This means that we have a lot of components. So I don't know how many you have in the current system that we're building for the UAE. It's probably 40 components. That seems about right, something like that, 40 individual instances of little processing units that we build and then deploy as a single kind of thing, all running individually, independently of each other. For each of those components, we have a common delivery style, a common CI style that we apply. So some of this will seem familiar actually with Dan's talk as well. You'll probably notice some similarities in approach. We start off, so we use Git, primarily we use GitLab, and we use GitLab CI as the continuous integration tooling, which is, if you haven't heard of it, is kind of an alternative to Jenkins. It's a little bit of a different style, because so in Jenkins, where you go and you define jobs in the Jenkins UI and you link it to an SCM or you link it to multiple SCM repositories. We've heard some of the issues that you've had around where you have jobs defined in Jenkins. Classic thing I've seen in there is that people write whole shell scripts inside of Jenkins for running a build, and then you don't ever check it into Git, and your system goes down and you lose all those lovely bits of build scripts that you wrote. GitLab CI approaches it from a slightly different aspect. You have to have your script or your kind of build definitions in CI, and it automatically runs them for you. Because GitLab CI is the version control and the CI, they're very closely integrated, and so you're building from the kind of start, that premise of your build scripts and your build definitions are just in version control immediately. That's the only place that you have them. So typically what we start off doing is, so I've got the kind of branches that we work on here. So we do have a branch-based delivery style as well, similar to what you've heard before. We typically start in a feature branch. So one of our team, they'll work locally. You can run all of our pipeline, at least on the component delivery side, locally on your machines as well. So typically somebody will start some development locally. They'll write their build scripts, they'll write their tests, they'll start running it locally, and they'll be committing and pushing into a feature branch repository that they have. A feature branch on that repository. Whenever we push to a feature branch, so as soon as it goes into GitLab CI, it's just one of the things that GitLab CI does. It always automatically runs a build for you, and it'll run the build definition that we've put into our repository. So what I'll do is I'll just talk. I don't want to forget some of the things that we do, because I wanted to talk through a little bit of the tooling that we use. The build tool that we use is Maven. Maven's an awesome tool. We haven't really mentioned much about the kind of build tooling that we're using. I've kind of had experience in the past of sort of Make, Ant, Maven, Gradle, various different ones, shell scripts. But Maven's one that we've settled on as a kind of a business. We're very uniform in the way that we approach our delivery and our CI. Maybe it's easier to be when you're small. That's a fair consideration, I would say. But so we take Maven, and what we've actually done is we've utilized it. Maven, the awesome thing about Maven, it's got an absolute ton of very helpful plugins. They're super simple to pull in because Maven does all of the dependency management for you. It also does the dependency management of build plugins for you. So you just write in your XML build descriptor, I want to use this build plugin, and it will pull that in for you automatically from public repositories, which is really helpful. Where I've experienced things like Ant and things in the past where you end up doing a lot of that management yourself, and that actually adds a lot of overhead in the way that you work as a delivery team. The other thing that's worth mentioning as well, and when I talk in these two stages about the tooling that we use here, is that again we've created a kind of a company-wide approach to it. So we have a top-level Maven build file. Effectively, it's like a company-wide build file that defines these are the common build steps that you have to go through. If you're building Java, you run this set of tools, and I'll talk about what they are in a sec. When you're running tests in your Java, you run this set of steps. So it's unit test, integration test, you run this coverage tool and all of these things. So we apply a company-wide policy, and then when you get into the actual Maven build file that you put in your individual repositories, you don't think about any of those things. They're just there. You just import the parent build file, which is just a couple of lines at the top of your file, and you get all of that pipeline applied automatically. What we really wanted to do with it was to remove some of the inconsistency and some of the thinking time that it takes to start up a new repository. What we found before we had this was that you'd go into your one repository and you'd be like, oh, okay, cool, they've turned on code coverage, but oh, they're not really actually even looking at the numbers, it's not going to report. And then you go to the repository, the next repository, it's like, oh, they haven't even turned on code coverage, and oh, there's no unit test. Oh, this is really terrible. So there's no consistency. And unless what we found is that actually there's kind of two aspects for it. One thing was we didn't really want people to have to waste time thinking about that stuff. It's like, many of these things are solved problems, and we shouldn't really be having to spend time as developers to think about how we're going to approach making sure that we do static analysis and what tools we're going to use and things like that. Like actually there's not really a lot of creativity there anymore. Those things have been solved. So we just wanted to make this a common thing that just gets applied. And also that consistency is super important so that we can say when we deliver to customers, yes, all of our components, all of our code that we've delivered into this project have followed the same standards and we've set the same quality bar for them. So once you pushed into here, as I say, you automatically trigger a build. So this is just within your feature branch. So you get a feature build that kicks off. The first thing that happens is you get your code build, and there's many stages to this. So I'm gonna quickly go through my notes because there's about 7 or 8 tools that we apply here. So kind of pre-build, we apply some analysis checks on it. One thing that we brought in to apply straight away is Checkstyle. So if you haven't heard of the tool, it's one that applies common styling to your code. One thing that we found again is that actually freedom of creativity with the way that you write code is good, it's nice, but also actually it is useful in terms of maintainability of your code. If it is consistent enough across repositories that anybody can pick it up and read it and start to understand it. And we found that actually code styling and the shape of code helps readability and helps understanding over time. We apply PMD and FindBugs, which I don't know if you've heard of those, but they're static analysis tools for Java. I think maybe they can be applied. I think maybe PMD applies to other languages as well. But they do the usual kind of static analysis, looking for bugs in code, like common mistakes. Again, we're applying a consistent level of quality across the code in terms of that analysis. CPD, which is it's called copy paste detector. Which actually looks at your code. If there's any significant chunks that have been copied and pasted between them, it flags it up and it brings that out to you. It's worth noting actually all of these things I'm listing, they will fail your build. You can't build unless you pass all of these. Okay, so if you copy pasted code all through your production code and it's like, oh, you've got there's this 5,000 lines of code that you've copied into 2 or 3 classes, it's going to pick that out and you're not going to be able to complete your build and actually get your feature branch merged until you have sorted that out, because we believe the quality of the code and the maintainability of it is really important. And when you copy and paste stuff, it reduces the maintainability of the code. The other one we have, so I mentioned FindBugs, there's also FindSecBugs, which is a security scanning, a static analysis scanning tool as well. It looks for many of the things that you have, like it's OWASP, many of the OWASP top 10, like the common vulnerabilities. And another one, CWE, I remember as well, which is like another set of common vulnerabilities that they say in software. This does static analysis. We do also do kind of live penetration analysis, which maybe cover later on. It does that on code. We run that on every build. Again, it will fail it. And we also do some of the things we brought in a little bit more recently, maybe in the last 6 months to a year, was CVE scanning. So, you know, CVEs like vulnerability reports on our dependency libraries. So where we pull in open source libraries from the internet, you know, whatever libraries, I'm not necessarily saying open source is any more vulnerable than any other, but we pull in libraries from Maven Central often, where we have these dependencies. It's quite hard actually to keep track of whether they have had vulnerability reports made on them, public vulnerability reports. It's quite a difficult thing. In the past, where I've had to deal with this, it's all been a manual process. So I mean, give you a bit of context, actually, my background before Snowflake, I worked at IBM for 14 years in software delivery, and there was a very heavyweight manual process. So there was a whole internal team who were dedicated just to disseminating vulnerability information to the rest of the company, and you would have to report back and you'd have to go and fix it. What we actually wanted to do was make that a part of the process. Again, actually, what we also find is that if you put kind of reporting on vulnerability things you find, or dependencies that you're using, or licenses that those dependencies have, a manual process that developers have to remember to do, they probably won't remember to do it, and then you just get inaccurate information. So we really wanted to just get that automated, so that again, it's not something you need to think about. We can be confident that we can say that there are not known vulnerabilities and the dependencies that we're pulling in. And where we do find them, we analyze the vulnerabilities and we decide we either upgrade to try and avoid them, or we exclude, but we record why we've excluded them so that we know why. And this is just, again, this is using another Maven plugin, which is publicly available. We haven't done any development. Now, this tooling that we use for this, the kind of build analysis and quality control is developed in-house. It's all publicly available. And the other thing I touched on was the license scanning as well. So another aspect that before I've always experienced is quite heavily manual, is when you pull in dependency libraries, you have to go and look, what's the license on this thing? Oh man, it's GPL. Okay, this is pretty bad. So we can't use that one. We've got to go and look at this, that, and the other. Actually, it turns out there's a Maven plugin that you can use, which will go and, when it pulls in your dependencies automatically, it actually goes, looks up the dependency, the license of that dependency library, and we'll go and check that against a list of ones that you've approved. So you just set again in that top level build file we've got like MIT, BSD, Apache software license, those kind of things in there, and it just goes and literally does a match against them. And if it doesn't match one of the ones you approve, it fails your build, and then you go and you deal with it. But it's making that stuff visible and unavoidable, but also removing most of the time it just works and you don't have to worry about it. So it removes the day-to-day thinking of it, because that makes you miss things and it makes you not do the process. Are there any questions on that quickly before I go into the testing? Does anyone have anything on that? Cool. I know I'm talking quickly. There's a lot to cover in 15 minutes. Thank you very much, John. Very kind. So, awesome. So if you make it through all of that, and it builds your Java code, I should say as well, right? If you make it through all of that, then we get on to the testing phase. So at the component level, we typically have 3 different levels of testing that we apply. So we do unit testing, pretty classic. We just use JUnit, which is pretty standard for Java. And we have also, along with that, we have integration testing, where it's not integration in the sense of we take the whole component, we put it in an environment, and we integrate it with a bunch of components. We actually do in-process integration testing. So what we'll do is where we have many microservices, what you find with actually microservices, they tend to have lots of kind of interaction points with other systems. In our case, most of the interaction happens with our event messaging pipeline, which is Apache Kafka. And what we actually do for our integration testing is we spin up, in the process of the test, we spin up Kafka and any of the other dependency servers. It has maybe a mocked out REST interface that simulates the kind of other components that it would integrate with. And then we spin up the whole component and we run tests against it and we drive data through it as if it was in the real environment. But it allows us to kind of poke it and do horrible stuff to it at the same time more easily, in a more lightweight way with faster feedback than it does when we get to the system testing level. Out of those 2, we measure coverage. The usefulness of coverage as an indicator of the quality of your testing aside, we do set a quality bar, a coverage bar at least, which is some decent percentage of branch coverage. It doesn't really tell you that you're writing good tests, but it at least tells you that you've written tests. And that's the thing that we had in the past. Like, well, okay, if you can have some tests in the repository, but it's hard to tell whether you're really hitting 10% or 100% of your code. And it still doesn't tell you if you have quality, but at least it's something. I'll talk a little bit later on about thinking that we have for the future on that. But then, so you have to get through that. Again, we've actually set that coverage bar to be a hard limit. So if you don't hit the coverage limit, it will fail your build. So again, you just kind of, although it sounds really harsh, all these things that we have in it, actually when you're doing it every day, it just becomes a natural part of your development process, and actually end up just kind of writing in that style. It just works. Again, you can run it all locally, so it's not really a problem. You just do that local cycle of development on your machine. So you don't have to wait for a full CI build on your kind of CI hosts and stuff to be able to get this feedback as well. Hello, yeah, go for it, please.
So you say that's kind of become sort of like the de facto way of working. When you get new employees coming in who haven't come from that kind of background, aren't used to that kind of ethos, how do they
That's a good question. So I mean, I would say the way that we approach recruitment is to recruit people who understand the way that we work. That's not to say that they necessarily do exactly the same things we do, but it is that they have the same enthusiasm for software quality, software delivery that we have. And actually, what we really like is if people that we hire from external come in and bring new ideas, because you can get a little bit enclosed and a little bit in your bubble. And although we think this is kind of cool, actually even today from the couple of talks we've just had with like Steve and Dan, I've already picked up some new stuff that I think we can take in. So I think we tend to aim. I mean, one of the other things that's been brought up as well is how important collaboration between developers and things is, and actually perhaps historically that hasn't been valued as much as it is in the modern day. And that collaboration is actually the way that people interact and the way that people approach problems is one of the key things in our hiring process that we look for in individuals. We actually, maybe we're a bit weird like this, but we don't actually look at so much the technical prowess of the individual. It's more about how you approach things, how you can interact with people, because we believe if you're a technically minded person and you're pretty smart, you will probably pick up whatever you need to pick up. Actually, that's not usually an issue. The issue is you bring someone in, they can't understand your practices or they can't interact with people well, and then you have problems with that individual. And it's actually hard. It's harder to change somebody's personality and the way they approach things than it is just to teach them a new technology or whatever it may be.
Cultural thing you've got.
Absolutely. Absolutely. Yeah. That's right.
Okay.
No worries. Yes, so on the testing. So we've made it through that bit. A third layer of testing we have. So the thing I didn't mention is that we're completely Docker based. I think Dan mentioned it. Who knows what Docker is? Awesome. That's cool. All right. That's good. A few years ago when you asked that question, no one would put their hand up. Oh my God. So that's really cool. So we're completely Docker based. Every microservice we build is built as a Docker image and deployed as a Docker image. We run on top of Kubernetes as well in our deployment environments, whether we're installing on-premise or in the cloud, wherever it may be, or actually for local testing as well when we get to system testing, which I'll talk about in a sec. So what the final part of this kind of test and build stages is that we build the Docker image that we'd actually deploy. And what we do at that stage is we do another level of testing. So we actually do a Docker packaging test at that stage. It's kind of, you could call it an integration test. I prefer a packaging test to try and ensure that, it's when you test at the kind of the code level, you can do unit testing, that's awesome. But actually if you break the way that your code is configured when it's actually deployed and you don't find out until you've actually deployed it, you've wasted some cycles getting to that point. Because you write some code that takes in a new configuration option, whatever it may be, but actually you don't configure your packaging and the way that you deploy to actually accept that configuration, or you put in the wrong parameter or whatever it may be. And you don't discover that stuff until you actually integrate it way at the system level. So what we do is we actually spin up, I mean the handy thing about Docker is it makes it really easy. We spin up the actual Docker image that we've just built once it's passed all of these other stages. And we spin up its dependency components again alongside it in a full we use Docker Compose for this. So so we'll bring those all up next to each other, and again we'll drive some data through it. We can write scenarios. It's actually all of these tests are driven out of JUnit in their style, and we've just built a little utility framework that allows us to spin up Docker containers on the side and then poke them and get feedback from them. So at that point we are very confident in terms of the quality. We're confident that we could deploy this thing and have it run in our environment and actually interact with the other components that it sits next to. So that's kind of where we reach the end of our CI pipeline. So we've gone through all of those stages. That's what we do. Around this point, so once that kind of builds, we have a human merge review process. So we always have a merge review on any piece of code. So you cannot merge into our develop branch, which is kind of our sort of head. You can't merge into there unless you've had a merge review. So sometimes that goes in parallel. If you're pretty confident your builds are going to pass, you can get somebody to start merge reviewing at the same time. The cool thing about GitLab CI is if they click the button in GitLab CI, GitLab CI, by the way, does all the merge reviewing nice stuff where it gives you all the diffs coloured and all of that good stuff. If they click the button to merge, GitLab CI won't merge it until the build passes. So you can just do the review, you can click the button, I'm happy with the style of the code and how you've approached it. GitLab CI will make sure that it completes all of this testing before it lets you actually merge into the main branch, which is really cool. GitLab CI is awesome. And And then so the thing that we have there, so develop is our kind of branch. It's kind of our head branch. That's where you're merging in your feature with everybody else's. So that's the first time you're kind of fusing all your code with everybody else's one. And at that point, it's the same pipeline again. So we apply exactly the same stages and all of the same tests, all of the same quality bars and things at this level as well. But we also just have this additional packaging and deployment. Deployment isn't actually deployment into an environment. In this case, it's deployment to our internal Maven repository, so that kind of, or our Docker repository, so that image is available for use in deployment later on. And then if that all goes well, everything's merged in, we'll do a release. And we use a Git flow. Actually, there's a Maven plugin for Git flow, which allows you to do releasing into another branch and also merging in hotfixes and things like that as well. And that goes onto our master branch. One of the things we do on master is to rerun that pipeline. And I think that's primarily because sometimes you might have other branches merging into master. We don't typically actually do that. Usually it's just developed to master. So one of the things that we are considering is whether actually this run is really necessary. We could just create a release, because at this point, this code is exactly the same as this code. So you're not really getting any value out of this. So these are some of the things that we might start trimming out as we try to kind of reduce the amount of time that we're spending in builds and so on. Yep, hello.
So when do you do sort of like, what I call it, user acceptance testing? So, as you said, the aerospace industry is very regulated, and I understand why they use waterfall, because I used to work at Airbus in Guildford.
Right.
Risk is measured in terms of human lives. Do you understand? So, when do you do user acceptance testing or like system end-to-end testing? Because everything can work fine in Docker, all your images, your playbox, your sandboxes, your virtualization, all those things work fine. But once it gets into the user's hand, maybe the air traffic controller in Dubai or wherever, they will use things in ways that no developer could have envisaged.
Yes, indeed.
So when do you do that?
That's a good question. So, I mean, so the next thing I was going to talk about, it looks very similar. It's almost a game of spot the difference, is our deployment pipeline. So I'll talk a little bit about our system testing. I would say we do try to follow agile practices as much as we can, which involves trying to gain feedback from our stakeholders as often as we can. So we demo to the customer. We try to get them hands-on. I mean, so where we do kind of proper agile delivery into some of our cloud environments, we will pass that to our customer at least in a kind of a testing environment on a sprintly basis, and we'll make it available as you kind of should do, so it goes out into production. With the kind of the more waterfall-driven customers, we do try to do regular demos with them. So we have at least sort of 2 to 4 weekly demos with them where we'll demonstrate the functionality, we'll go with it, they can ask questions, they can give us feedback, and we try and feed that back into the production of the system. I wouldn't say they've had a lot of time for user acceptance testing prior to release. So it's very difficult at that stage. So in that process, we have followed the more traditional style. So towards the end of the project, we will have a factory acceptance, we'll have a site acceptance, and we'll follow that systems engineering style process with them. So.
Remember when the Terminal 5 was when it went live, 2 days after that, all the computer systems essentially gave issue. I can't remember how many years ago. And only last week, TSP migrating from Lloyd's. You can see people can't access their accounts and all that bad reputation.
Yeah. So I mean, to talk about this UAE project as an example. So actually, I mean, the level of testing that we go through with them is actually pretty exhaustive. So unsurprisingly, we're very regulation driven. So we don't build, I mean, it's worth noting, we don't build safety critical systems. So these are adjacent to safety critical systems. They feed them with some data, but this is not safety critical in itself. So we don't build to that same assurance level that you have to with safety critical systems. But what we do go through them is we do a very heavy, it's a week long, we've actually got one coming up in a couple of weeks, a week long factory acceptance test. So although we try and do all the demonstrations to them through time and gain feedback from them, I think the more traditionally minded customers don't actually even give us feedback, even if they think of it, I would say. So we don't always get the feedback that we're desperately asking them for. And so we do a week-long factory acceptance where they are actually in the office with us. We're running it in front of them. They can ask us to try different things out. They get a bit of a go. That's in advance of us ever getting to their site. It's probably a month or two before we get to their site. On their site, they have three, in this particular case, they've got 3 deployment systems. They typically have at least 2, but maybe in this case 3. So they'll have a research and development system, which is a bit of a free-for-all. You can do whatever you like there. They've got a backup air traffic control center, which is their kind of emergency air traffic control center, and then they've got the primary air traffic control center. And so what we tend to do is we roll through those 3 environments. And what we've actually done, it's quite a lengthy process. It's much longer than we would normally like. We'd like to get much earlier feedback from them, but you have to work within the kind of confines and the constraints that the customer has. So we rolled first into their research and development environment. We ran it there for some time. We went on-premise with them, so we flew out to the UAE. We ran a week-long set of tests with them again there, where they spent time actually using it, giving us feedback, clicking through, dealing with the flights, looking at the data going through the system and so on. It's only when we pass that acceptance test that we can then move into the next site, which is the emergency backup site, and then we move into the primary. So it's fairly exhaustive. The other thing, and I'm very aware of time, oh my goodness, 3 minutes. So I'll be super quick on this. So, I mean, I hope, did that answer your question at all? So the one thing I might talk about on this one mainly is just, so this is our deployment pipeline. It follows a very similar style. It's worth noting that, well, actually what I didn't mention on the previous slide about all of those quality bars we put in place, we apply pretty much all of them to our test code as well. So one of the things that I've heard a lot in the past is that, it's not production code. That's not production code, don't worry. It doesn't have to be that good, don't worry about it. Actually, what we believe is that if your test code is not good, you cannot be sure that your production code is good. Because bad test quality can lead to poor quality tests, which leads to poor quality production code. So we apply all of the same Checkstyle, static analysis and everything on our test code as well, the unit test, system test, absolutely everything. So it's all consistent, it's all maintainable, it's all high quality. So when we get out into our pipeline deployment, I'll really quickly whiz through this. It's effectively the same process in terms of build. So we build whatever, pull together, assemble whatever deployment artifacts we need and so on. Again, if there's any code in there like system test code or anything else, we apply all of those quality bars in there. We deploy, so because we run on Kubernetes, we actually do a similar thing to the islands that Dan talked about. We use Kubernetes' feature of namespacing to create isolated full deployments of our system. So when you spin up a feature branch, GitLab CI automatically builds it. Awesome. We actually automatically deploy it, and you get your own namespace, which actually has a full deployment of the system within it. So it's like you have your own instance of the system that you can run system tests against for your feature branch. And then we have the reason we're actually fairly confident when we get out to the FAT and SAT, to come back to your question, is that actually what we've done with our acceptance testing that we demonstrate in front of the customer, that's typically a very manual acceptance test. It's like click around, see where it goes. It's far too late for us to wait until the end of the process to go through that. So we actually automate pretty much all of those acceptance tests in our system test environment, so that when we run through them with the customer at the end of the end of the delivery process, we've already been through them a million times before, and we're confident they will just work. And we run them every time we spin up. I'll say, so what actually one of the interesting things, so we certainly run all of those tests in our kind of master environment. Well, one of the things that we've had to work on is how we get effective fast feedback here. So what we actually do, how we approach it, is that in feature we run a small subset of kind of smoke sniff tests. You can run as many of the tests as you want. So if you're making changes in a particular functional area, you can run selective tests very easily. But we wanted to keep that a really fast feedback cycle. We can take a little bit of risk. If we get into develop and it's a little bit broken, okay, we can deal with that. We just fix it straight away and we just get back on it. That's okay. So you kind of mitigate some of the risk here. Develop, we run a broader set. It's like, the shells of the onion classic. We run a broader set of tests. And develop covers most of the kind of core functionality, but isn't the full exhaustive suite because it's way too long. Again, we want that fast feedback cycle at different layers. And then we get out into our staging environment, which is the master branch, and that runs the full suite of tests, which is typically overnight. It's quite long. And then coming out of here, which I haven't drawn on, is the actual deployment. So either into our kind of cloud environment, or it can be into on-premise, although actually that push out onto the on-premise sites is very infrequent. We actually have an internal fake on-premise production that we push to as often as we can, and we can typically do that. If you get a change in, you can and you do well with all the tests, you can typically get it into that production environment the next day. So it's a pretty fast turnaround. Same day, I'm hoping. Hello, yes.
What is the limiting factor on why you've had to reduce the test sets down at each stages?
Sheer time and lack of hardware,
So
I think.
it's compute
Yeah,
basically.
yeah. So, I mean, what we actually found was that we have it's quite a complicated timing-based distributed system with a lot of services interacting. And when you really hammer a load of these namespaces onto a small set of hardware, we found that it changed the timing really significantly. And actually, what we found was it wasn't really bugs in the system. We found loads of bugs in our tests and our test approaches, and we're really trying to squeeze a load of those out. But actually, we're so constrained in terms of the hardware at the moment because we don't have enough budget to really expand that as much as we'd like to. In my mind, I would love to have like a farm of maybe 20 different environments that I can just parallelize test again, and maybe they'll run in a half hour or an hour. We don't have that, so we end up running all of these tests sequentially pretty much, and it's like a 4-hour run or 5-hour run, which is not too long, but it's fairly long. So I'd really like to get that cycle time down. That's really one of our goals.
How do you measure that cycle time or track it?
It's actually in the CI build, so we can see it all there. GitLab keeps track of that all for you. Yeah, so you can see all that information. Although that is one of my main kind of not so awesome bits. Do I have time to go through these last 2 slides? Go on, John.
Does it?
Is that okay? I'll be really quick, I promise. So I've probably already talked about some of them. Sorry to keep you for so long. I did say there was a lot to talk about. So I'm just really going to talk quickly about awesome bits and not so awesome bits. So fast feedback cycle, I think we talked about this already, but that componentization, actually the microservices approach helps us a hell of a lot, because it's like, oh, when I make a change in this component, I know it's built, tested, ready to merge, review in 5 minutes probably. Even that time we're not happy with. It's always too long, so we're always trying to trim down the time that we spend on these things. So we look at our Docker tests, say recently, we're looking at our Docker tests and we're like, oh, the way we approach this actually is terrible. We spend ages bringing these Docker containers up. There's different ways that we can approach this that make it faster. And if it shaves off another 30 seconds or a minute and you're doing that 50 times a day, you could save a lot of time. So quality control is high and we have consistency applied across the business. I say we probably have an advantage because we're smaller. It's easier to do that. The quality extends beyond the production code, the test, even shell scripts. This was something actually Andy kind of, I think, introduced us to, which is, shell scripts are often a bit ignored. Our infrastructure, our deployment scripts. There's actually a tool called BATS. So for those of you from British American Tobacco, you might quite like that name. But there is the BATS tool, which actually allows you to write shell script tests to unit test shell scripts. And we're out because, again, our belief is, we have a bit of shell scripty wrappering, probably most people do, on the way that we deploy out to our production environments. Well, that's touching production. We're not testing that thing, and no one tests that thing until you get to production. Actually, sometimes it's really hard to tell if that's going to work until you get to production. So we actually write unit tests on a whole bunch of our kind of wrapper shell scripts as well, which is really cool. Highly automated, as I say, we can do better. You can always do better. And it's all driven out of version control. I think I touched on that one enough. The not so awesome bits, stuff that we're still struggling with. Really hard to update dependencies. This is one that really can kill our productivity sometimes. So where we have this componentization and we actually have a lot of repositories, if you have a dependency that spans a lot of those, maybe like a utility library or a runtime framework, because we try to be sort of clever in the way that we develop stuff to abstract out a lot of the stuff that you typically do all the time as a developer and do repeatedly across components. But that means that you get dependencies that span many, many repositories. It's really hard when you update one library that is common to maybe 30 projects to then go out and touch all those projects, because our process is actually quite heavy. We've tried to make it light, but it's heavy when you have to do it lots of times for one change. So we need to work out a way of getting through that, because I think that'll save us a lot of hassle. Pipelines contain duplication. So this is the one I touched on earlier on, actually, in terms of those tests and staging. So I won't go into that one again. Maven doesn't fit brilliantly with the GitLab CI build test. So GitLab CI It's like, okay, you can define steps. It's really neat. So you can do like build step, test step. You can do a packaging step, a deploy to whatever your repository step or deploy to your environment step. And you see that drawn out as actually a visible pipeline. And you can run those individual stages and rerun them in GitLab CI individually, which is quite nice. Again, it's fast retries, fast iteration and whatever on it. Maven doesn't really fit that because Maven likes to just run the whole thing through from scratch. And so we've kind of had to do some nasty magic to get some of those bits to work. And it doesn't completely fit the bill yet, but we'll fix that eventually. We will fix that eventually. Lack of visibilities. This was probably one of the things that I think was touched on earlier on as well. So the tricky thing with having all of these repositories is that it's hard to see what's going on across all of them. One of the things I keep thinking of in the back of my mind is using something like Sonar or Sonar Cube, I think it's called now, which gives you some kind of overall project visibility. You can do reporting out into centralized tools to say, I'd really like to say, what version of dependencies are all of our projects on? What dependencies are they using, so we can discover what complete set we have across all those. What versions are they on, so we can see if they're really out of date. Because actually we don't rerun builds unless there's changes. And also just the quality levels that have been applied there. So like what is the coverage across all these things? So that when we generate ports maybe for customers, we can say, here you go, these are all like 90%, 95%. And that some of our quality checks can be a bit overzealous. So we do apply them to test code. Sometimes it can be a little bit frustrating. It kind of picks you up on a particular format of your thing and stuff like that. Copy-paste detector, sometimes we let that slide a little bit in some of our unit testing where you have a lot of like mocked out common code, but you actually don't necessarily want to centralize that. You actually want to keep those separate sometimes across your unit tests. They can be a little bit overzealous, but we do allow some flexibility with those. We don't tend to be too strict in certain cases. So you can actually, in your test code, kind of exclude those and put some ignores in sometimes. But generally, 99% of cases, we apply the full stack there. But that's something we're still working on. We like to hone those rules that we have for the static analysis and things like that to better support our use. But I think that's it. I think that was everything. Oh, the only thing I was going to really... Oh, this is... I'm so sorry. The only thing I will finish like this, like couple of really... I won't actually talk about the GitLab CI one, but just a cool thing to think about. I said earlier on about how we do the unit testing and that coverage is not a good indicator of good tests. There was a tool that I hadn't heard of actually before a month ago or something like that. I can't remember, was it you, Andy, who pinged it out, or Phil or somebody? You did, yeah, you Googled the hell out of it. It was a thing called mutation testing, which actually is a test of your tests, a test of the quality of your tests. What it does is it actually goes and modifies your production code that you're testing and then sees if your tests fail. So whilst you can have coverage, which is great, if you're not asserting things, the behavior of your code, it doesn't matter. It doesn't matter if you have the coverage, right? And so what it actually does is it goes and it'll replace some of your statements with like throw an exception, or it'll make your loop run once instead of 50 times or something like that, which should have been triggered. It will go and change constants and stuff like that. So it goes in and actually instruments the bytecode in Java and modifies it all, and then it gives you a report back on actually how good your tests really are. This is something we want to bring in so we actually get a genuine measure of how good our testing is. But it's just a bit of food for thought. I know there's no time for questions. Sorry for talking for so long, but thank you anyway. Cheers.